The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Jack Holt, a professor in the university's Lunar and Planetary Laboratory. Welcome, Jack. You're going to be leading a study of glaciers in the Arctic. We live in the desert Southwest, so why do we care about glaciers in the Arctic?
Well, glaciers in the Arctic are, I would say, everybody's problem because they are changing very rapidly and they're contributing to sea level rise. They're kind of hitting out of their weight class because we normally think about the Antarctic ice sheet and the Greenland ice sheet as being the big players in sea level rise. And in the long term, that may be true. But in the short term, the glaciers that start out in, say, mountain valleys and go down the hill towards the ocean, scattered across the Arctic, are contributing a very large fraction of current sea level rise, even though the total amount of ice in them is very small compared to Antarctica and Greenland.
When we hear about ice in the Arctic, we usually hear about the floating ice cap at the North Pole, but that's not what you're going to be looking at, right?
That's right. This is ice that is basically on land. It does sometimes flow into the ocean.
And that's why it can cause sea level rise.
And that's why it can cause sea level rise. Or it can just be melt, runoff from surface melt from the glaciers that makes its way into rivers that make it, they get into the ocean. So it doesn't have to be, flowing directly into the ocean.
What are the main places you'll be studying?
We have 4 main areas that we're going to study these glaciers, and they're where the glaciers are changing the most rapidly and we have the least information. That's Alaska combined with the Yukon in Canada. We're going to northeast Canada, and then we are going to southeast Greenland, and then we are going to Svalbard, which is a large island with many glaciers north of Norway.
You mentioned that this is using aircraft, but it's actually a NASA mission. What's the advantage for the aircraft?
Well, first off, we can cover a lot of territory. So you can do these measurements on the surface, but it would take, many teams of people a long time to do these measurements over even just a few glaciers. So with the aircraft, we can cover many more glaciers over a short period of time.
How about compared to satellites?
Satellites can give you very good coverage, but a problem is that they cannot measure snow depth in a reliable way yet. And they also cannot measure ice thickness directly. So these are things that we have refined over previous projects over the past decade or so in terms of techniques that you can use from airplanes.
Another thing that's different from a standard NASA mission is that instead of a team of scientists proposing a mission, NASA just selected from among ideas submitted by individuals, and now you're building the team, correct?
That is correct.
What advantages and challenges are you finding in that system?
That's a good question. It's an interesting process. NASA's trying this for the first time for something of this scale. I'd say the advantage is that it allows time to put together the most optimal team, and it's very open and inclusive, so anybody can apply to be on the team. So instead of knowing from the outset who's going to be part of it, you open it up, and so it's a competitive process.
How long will this project run?
It will probably end up being 6 years. We will have about a year and a half of planning, science team selection, integration of instruments into the airplane, and then we will do 3 seasons of flight operations between February and May of 3 successive years to cover all 4 areas. And then we'll have about a year to a year and a half of data assimilation, modeling, projections, that type of thing.
Well, good luck with the mission.
Well, thank you, Tim.
Our guest today has been Jack Holt, who is leading a new NASA program using aircraft to study glaciers throughout the Arctic. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.